Hi, and good morning, everybody. Welcome to our kitchen table today. So my name is Julie. I'm with 360 Energy. I'm going to introduce David Arkell just to discuss a little bit more about 360 Energy. We're hosting the webinar today.
Yes, thanks, Julie. And good morning, panelists and participants that are listening to this session. It should be we had a little early session, so I think just by the sampling of discussion, it's going to be quite interesting. Just very quickly, just so everyone knows, since our foundation in 1995, 360 Energy has worked with customers to improve their understanding and use and price of energy, which has in turn led them to reduce their carbon emissions. Building on this heritage, 360 has developed a 7-step program to help organizations achieve net zero carbon. Customers can participate in full in the program or take advantage of individual modules, which will include carbon accounting, renewable energy procurement, technology solutions, and carbon offsetting, similar to what you're going to hear today. In Canada, we're really fortunate to have the vast amount of resources available. That's not just natural resources, but also the energy and carbon expertise that you're going to hear about today. And this goes from coast to coast. It's now our opportunity to demonstrate to each other in Canada and to the rest of the world that Canada does and will play a leading role in managing energy and carbon. In today's session, you'll learn about the expertise that is available to help customers in their journey to net zero. And I look forward to the panel's discussion from people from Canada and around the world. I want to also thank Richard Adamson, who actually organized this event and getting the panelists in place. So it should be quite an interesting discussion. So thank you very much, Julie, and I'll pass it back to you.
Okay, so thanks for that, Dave. Before we get going, I just wanted to go through a few quick housekeeping notes. So before we have our panelists introduce themselves, we do definitely welcome questions during this webinar. We are going to answer them towards the end. As you may be familiar if you've joined our webinars before, we do keep the people on mute throughout the webinar just to keep down the background noise. I do recommend and encourage people to use the question function in your control panel for the webinar. We'll be monitoring this and we'll be asking questions that pop up here towards the end of the webinar. Beyond that, I'm going to introduce our panelists today. I'm going to actually let them introduce themselves. The webinar today is Hubs and Clusters, Opportunities for Industrial Carbon Emissions Management. And as David suggested, we've got a good panel of experts here, and they're going to guide us through a bit of a discussion today and make sure that we're far more in the know than we might be otherwise. So I'll hand it over to Richard. He's kind of our panelist today, and maybe he can introduce himself and start off our introductions.
I'm Richard Adamson. I'm CEO of Industrial Industrial Climate Solutions. I've been working in the space of industrial climate technology, policy, and regulatory for something over a decade now. So, then that makes me probably the least experienced of those people around the table. But the real focus here is on the industrial side. Carbon capture and storage has been discussed heavily, but it gets dominated by, in the US, there was a very heavy emphasis on coal-fired power, and therefore CO2 capture became a means of mitigating emissions from electric power generators, and that dominated the conversation. But in fact, use of carbon capture for industrial processes is probably more important as we journey towards the net zero world people keep talking about. And so I wanted to talk about how we could handle that, but beyond looking at carbon capture and storage as projects, a really interesting shift that's happening that those outside of the carbon capture space, to the extent that they're aware of carbon capture at all, may not have noticed, and that is especially in Europe and the UK and and more so in North America, there's a shift from capture point pipeline injection as being a standalone project to integrated systems with multiple emission sources, gathering systems and transmission systems, and multiple sinks for CO2. So industrial greenhouse gas management becomes more of a systems approach and less of a project and technology demonstration approach. I think that's a really important turning point that we're facing right now. I wanted to bring some people together that could talk to that. So hence the panelist here. Unfortunately, Tim Witcher from Shell was going to join us, was unable to. He was called away to a meeting. So it's the four of us here, and I'll pass it on to looking at my screen. I'm going to go clockwise and ask Robert Craig to introduce himself.
Great, thanks, Richard. I assume we're just having some short introductions here, and we'll have another opportunity to look at our slides. Is that right?
Incorporate your slides if you would, if you'd like to.
All right. So thanks. And yes, my name is Robert Craig, and I've been working in the carbon management space for a long career at this point. Probably spent about the last 12 years directly involved in working with large industrial energy companies in Western Canada on strategies to reduce greenhouse gas emissions. And so I have spent a great deal of time working and developing consortiums and large-scale technical projects around removing barriers and understanding technologies so that we can actually accelerate carbon capture and storage deployment. And I think that accelerating deployment is something that the audience is probably going to hear a lot about today. So maybe, if I could get my slide up, please, then probably I could talk a little bit about what's happening in Western Canada.
Okay, sorry, which slide, Robert?
There's one slide that has just Western Canada. Great. So let me talk to this one slide. I'm not going to read through all the verbiage, but for presuming there's audience members who are not as familiar with carbon capture and storage, it's about a big long set of words that might sound complex. It's not exactly. Carbon capture is really about removing carbon from any heavy industry emitting flue stream. That's the capture side, and as you can see, on the map, there's a great deal of capture throughout Alberta that we in fact had a look at. So we looked at infrastructure for capture. Those yellow nodes, in fact, are carbon capture areas and volumes. So that's the capture side. The second component is pipelining. So simply taking the CO2 once it's been cleaned up and compressed, and then moving the CO2 along a pipeline network or individual pipeline segment. And then we can either use direct sequestration, which means putting CO2 back in the ground at fairly deep horizons, or we can hopefully in the future utilize that CO2 for a whole host of other projects, or products that we'd like to see get developed. The only real utilization that we're doing today is for enhanced oil recovery. And again, sounds complex, but it's not really. It's taking older CO2 or EOR oil fields and then repressuring those oil fields in order to gain additional production. So it's making good use of the CO2 to get incremental production. And there's certainly a great deal of history of that in the United States and a little bit here in Canada. So we've done, and one of the consortiums that I worked with, in fact, this is a slide from the work that we did. I was their manager of technology and managing director. So we had a look at Alberta, as I said, and actually Saskatchewan and British Columbia, and did large scale carbon capture assessments where we built some technical and economic models to try to understand the business opportunity to move forward with this kind of an exercise. And you can see the work that we've done, plus the projects that are moving forward, have given us a great deal of background knowledge that we can use to move forward in the future with these projects.
All right. Thanks, Rob. Continuing around the loop, I'll go to Jan. Do you want to introduce yourself next, please? Jan, I think you're muted.
Like this, you hear me? So my name is Jan Hopman. I'm from the Netherlands, so I'm the guy from Europe. And sometimes jokes are made by that people from the Americas and from Canada don't know where the Netherlands is. So I made one sheet just in case. So maybe you, Dawn, you can show the first sheet to show what we're talking about. And if you click one time, so this is Europe. I'm sure you recognize this. And if you click once on it, then an arrow should appear. Yes, there is the Netherlands. So it's a tiny spot in Europe, close to the North Sea, which we think is really a sea. I think to your understanding, it's the size of a lake or so. So we feel sometimes small if we look to the Americas and to Canada. So in the Netherlands, I'm director of CATO, and CATO stands for CO2 capture. So basically it's the translation of CCS. It's a CO2 capture, transport and storage. And this is a consortium of, well, practically all parties in the Netherlands that are working or doing R&D on CCS, but also executing CCS if done already. So we started CCS around 25 years ago, studying about CCS 25 years ago in the Netherlands, but also together with the Norwegians, the UK. There is a lot of studying has been done in Europe on CCS, and in Norway, CO2 storage is practiced already for a long time. In the Netherlands, we did some paper exercising, and we were preparing for some projects in the Netherlands. Maybe it's good to go to the next sheet then. And then if you click 2 times, then you see the Portos and the Altos Project. So this is the Netherlands in a big size. There is one project preparing for CO2 storage. That's the Portos project in the Rotterdam harbor area. And so that's basically in this harbor area, there is a lot of refineries, a cluster of industries. And the idea is there to make one master pipeline, and everybody can deliver its CO2 to this master pipeline and bring it to the North Sea. And then in an old gas field, we can store the CO2. On the North Sea, there are plenty of gas fields, and the idea is to build this out to go further to the northwest, and to fill also the next gas fields that are in the area there. Another project, a bit similar to that, but they are a few years behind, is the Altos Project around the Amsterdam harbor area, where the main emitter is Tata Steel, with in the order of 10 megatons of CO2 per year, and part of this could be also transported to the North Sea, to an old gas field. There are also some other projects in the Netherlands on capture at waste incinerators, and also in the northern part of the Netherlands there is the Eemshaven, so harbor of Eems, that's another river. There are also plans, but they are not that far, not that specific at the moment. So this was the introduction of me and the Netherlands.
Good, great, thanks, Jan. And last but not least, Rob Mitchell.
Hi, I'm Rob Mitchell. I've been working in the CCS space for just over around 15 years. I come from an oil and gas background. I worked with Schlumberger in a subsurface characterization role for 20 plus years. And from that, I gained a lot of understanding about storage of CO2. I did spend time with their carbon services group, which basically enabled me to give me the bigger, broader picture about the capture, the transport, storage, also looking at the public acceptance and the policy and the legal aspects of CCS as well. After my career at Schlumberger, I worked with the Global CCS Institute, and now I'm independent. Couple opening remarks that I have out there about CCS. First of all, the global status. Back in 2000, the goal and ambition was to get 20 facilities up and constructed, and large-scale facilities they qualify at that time was over 400,000 tons of CO2 being captured on an annual basis. And now we're in 2020, and there are 21 facilities currently online that meet that criteria. So well done, we met that. The next challenge is taking it to the next level. So those first projects, a lot of them were a single source with a single sink, and you're taking care of the CO2. There might have been one or two operators that might be parties as part of those projects. The biggest challenge there is the risks and the uncertainties with the different aspects. I know some of the projects did have some delays and issues where you had a source that wasn't ready to provide for the sink, or the sink wasn't ready for the source, so it took some times and delays, which costs money. And again, it's all the risks on that. So we're going to be talking today about hub and clusters. Hub and clusters are an excellent way to manage those risks of a steady CO2 supply and a steady CO2 storage, or we can call it sink. If you have multiple players on each of those sides, then you can manage the risks of, well, you don't have the right supply coming in because you've got more suppliers that are putting into the pipeline. So if one of them goes down, you're not going to be effective. The whole pipeline doesn't shut down. So it's a lot about the risk management. We'll talk about that later in our discussions. I'm sure that'll come up. Canada is a prime spot for a lot of CCS applications. We've got over 1,700 facilities that have actually reported in CO2 emissions. If you look at the top facilities that are over 1 million tons of CO2, we've got over 59 facilities that are reporting over 1 million tons of CO2 that equate to about 166 million tons of CO2 on an annual basis. Now, you might think, well, that's all in Alberta, because Alberta is where CCS is at. Well, Alberta is the largest producer of CO2 and that has the most amount of facilities. Close to 270 million tons of CO2 being produced from the industrial facilities. So this is just the facilities, it's not from the cars and the transportation or from buildings, etc. Ontario actually comes in second at 165 million tons of CO2, then followed by Quebec, Saskatchewan, and then BC. I'm going to put a little note and a little star on there. There's also some from some large emitters from Nova Scotia, Manitoba, and New Brunswick. Now, of course, the biggest thing, and we'll be discussing this later on, CCS is not just applicable to power or fossil fuels, to oil and gas. And it's one of the common misconceptions out there that it's all just fossil fuel and it's all the energy coming from the oil and gas industry. yes, it is the top producers of CO2, those industries in Canada, but followed behind that is cement, steel, waste, and refining and chemicals. So there's other industries that will have applications for CO2, CO2 mitigation measures. The other part of things, so we're talking about sources, lots of sources. Western Canada is blessed with a lot of resources for storage. So with the oil and gas industry, they've done a lot of characterization of the reservoirs so that there's a lot of potential for storage. It is there. We know how to do it. We've been doing it for years. In fact, on a smaller scale, CCS kind of has been done for a long time, over 40 years, in the form of acid gas disposal. So in order for methane gas to be put into the pipelines, to be put into your hot water tanks, it has to be stripped of all the CO2 and H2S. And the CO2 H2S form what's called acid gas, and that acid gas has been just safely disposed of and stored of for over 40 years in Western Canada. So it's been done safely. So from the subsurface side of things, we have a pretty good handle of that, and we can definitely raise and discuss answers and questions about that. When you move further east, you don't have the same kind of resources for storage. However, there are some available, but there's other options out there. And we can learn from Europe. We can learn from other states. We can actually access and transport CO2 not just by pipelines, but you can do it by rail. You can do it by ship. You can do it by vehicles as well. So on a small scale, if you have small scale, you can actually tie into other stuff, and we'll talk about this in hub and clusters, where if you can connect up with others, then you can then get the transportation and worry about getting it to the storage site in a different avenue. So Ontario, you have the St. Lawrence River Seaway, so you can get shipments of oil coming in. You can theoretically ship CO2 out to go to an offshore storage site, or pipelines, or even local storage facilities where you might actually have some oil and gas in the neighborhood. So I'm going to put that out there, and then move it on to Richard, and we can talk about stuff as we go.
Well, that's great, Rob. There's actually, Rob's set the seeds for plenty to keep us going for this whole conversation. There's an awful lot there. But one of the things, so there's, just to recap, some of the things that I think are really high points there is the transportation question. In Western Canada, it's pipelines, but you're right. If you hit tidewater, the Norwegians have really taken advantage of the tidewater, the flexibility of shipping CO2 by ship. And they're looking at moving CO2 in from all kinds of adjacent countries and anywhere within the region. They're looking at bringing CO2 in for storage. And Jan, can you tell me maybe talk a little bit about the types of sources that you're looking at, using Porthos as an example of the Rotterdam side of things. What are the sources, and how do they play on the gathering system in Porthos? Do you have like major anchor tenants and smaller players, or how does that structure?
So for Porthos, it's good to explain how this works. Before Porthos, there was a project, which was the road project, where one power plant was going to one sink on the North Sea. So this was a single source, single sink thing. This was a coal-fired power plant, and basically due to, I think, public perceptions, etc., coal is going to be phased out in the Netherlands. So this was also the end of this project, and this project was more a demonstration that this is possible, that it's feasible, because we need to get used to that, especially in the Netherlands or in the rest of Europe. I think the Norwegians know that it works. They do it for a long time, but we want to see it in our own country. Then now the Porthos project is, so there is a main line which is organized. So the Porthos project is, I say the founders of the Porthos project is the Harbor of Rotterdam, which is a state-owned company, EBN, which is a state-owned oil and gas company, and GasUnie, which is the state-owned gas distribution company. So it's all state-owned, so transport and storage is organized by the state. And this was not without a reason, because all the industrials in the Rotterdam area, they said, okay, we are able to capture our CO2, but we cannot transport, and especially storing is too big, and it's not our cup of tea. So that means there is a facility, basically state-owned at the moment. In the long term, it will be privatized, maybe, but there will come a state-owned transport and storage part. Then the companies that are going into capturing the CO2 and deliver it to Porthos, in theory, it's all of them, everybody who emits CO2. But at the moment, because you need to start with some volume, there are 4 companies. Shell is one of them, a refinery of Shell. There is a hydrogen manufacturer. There is another refinery, and well, there is number 4. So they are rather big, but in the end, it will be 1-2 megatons per year. So that's the starting point. Later on, if this, so you need a certain amount. So there is one moment that they say, okay, we promise to deliver the CO2, and then Porthos promises to take off the CO2 and store it. So this, at one moment, they should sign the contract. There's also some subsidy involved. So a number of it's the chicken egg problem. Everything, no, not chicken egg. It's everything should come together at one moment. So at the moment, there are 4 rather big companies, relatively big companies, that take the lead for this.
Right. Thanks. And I'm reflecting on what's going on in Alberta right now. Just for those who aren't aware, just in the last couple of weeks, there's been an announcement that the Alberta Carbon Trunkline project and the Sturgeon refinery have come together. And I actually, can we pull up that one slide that one image that I sent late in the day? That's the one. Thank you. Just for people's information, up at the north end here is a recently commissioned refinery upgrader combination at Sturgeon, at the town of Sturgeon, that injects about 1.2 million tons a year of CO2 into what's called the Alberta Carbon Trunkline. And nearby is a nutrient fertilizer plant that puts about 250,000 tons a year in. And then down at the south end, there's an enhanced oil recovery storage site near Clive, Alberta, which is getting down towards Red Deer, which is the midpoint between Edmonton and Calgary. So this is, I think, 240-kilometer pipeline, and the path has been planned out to be able to cross near a number of potential storage sites and emission sources. So this is the beginning of what might be a hub and cluster arrangement in Alberta. Ironically, his Shell Quest project starts up near in that industrial heartland area, and the pipe goes north from there to a deep sequestration area. And the 2 pipelines cross each other, but are not connected, which is, I think we've lost an opportunity for synergies there, because from my perspective, part of the point of hubs and clusters is not just thinking spatially, but thinking over time. If we're dealing with carbon management systems, we have to be thinking in terms of decades and a robust system that's able to handle new industrial developments coming on stream, other industrial developments going off stream, perhaps enhanced oil recovery increasing or decreasing as fields come on and off, and perhaps swing loads for deep storage, but and we'll be talking about CO2 conversion. So having enough different sources and sinks connected to be able to ride out the storms over decades without the single points of failure of a, as you mentioned, Jan, a single coal plant as being your emission source. So, Rob, do you want to reflect? Yeah, go ahead.
Just wanted to make a couple comments on that. That pipeline is actually built oversized in order to facilitate future capacity. Mm-hmm. So instead of just sizing it for that 1.5 million tons today, it's sized for 14 million tons capacity in the future. So it's a bigger pipeline that they put in place to account for growing activity. There's two ways to do that. One way, you build it for today and then you twin the pipeline, which adds cost later on in the future, or you put money up front. Your construction costs are basically one time, so you save on the construction side later on, but you pay more in the steel and the pipe that you're putting into the ground. But yeah, it was over capacity, and I know there was a study down in the U.S. that kind of touched on how do you connect all those little sources to the sinks that you need to for adequate supply. In order to do that, and I think, yeah, and you're touching on it there, it's state-owned. They put in that MIT paper, in order for things to go forward, it needed to have some kind of a government involvement up front in order to facilitate the construction of that oversizing or that infrastructure that eventually will then be spun off into a privatized company later on. But it's too much to bear today. And I think, Rob, from your side, you come from the pipelines perspective. What's your thoughts on that?
So I would agree. There's a lot of value in trying to understand what the overall infrastructure is going to look like. Try to draw in as many sources of CO2 and markets. I mean, it's always better to pre-plan infrastructure. And as you said, you know, this project, this pipeline, it's actually high pressure, and you know, it'll move a great deal of CO2. So they're certainly planning for the future, and its location is good in terms of future enhanced oil recovery. So certainly that's always been kind of our approach to try and understand these things. And there's a lot of, in addition to the kind of removing risk and keeping we have experts in CO2 capture or running, you know, refineries. They're not necessarily experts in the pipeline side or even on the carbon capture side, so let alone sequestration. So good to have experts focusing where experts should focus, and that way you get the best solution in the end. And then the other piece of the enhanced pipeline is there was certainly some government support to move that pipeline project forward, and the government of Canada and Alberta both understood that there was some value in providing some public funds to get that initial infrastructure built, and then allow it over time to grow. And certainly the plan is not just for capture in the Adamson region, but certainly lots of discussion ongoing with reaching that pipeline out to the oil sands regions, maybe up into the Saskatchewan, Lloydminster heavy oil regions. So there's this is a very good starting footprint for a larger system.
Great, yeah. So I think people don't really understand how far things have moved in Alberta. There haven't been any new big projects announced. One of the conversations recently, but one of the conversations I've been having with engineering firms in the UK, which is also moving into hubs and clusters, was that many industrial emitters have expressed an interest in putting CO2 capture on their plants. But as soon as the conversation gets to the fence line, they basically say, well, you know, wait a minute, we're willing to invest on the capture process, and we're willing to get the CO2 to our fence line, but somebody has to deal with it from there. Once that infrastructure is there, or at least firmly planned, that opens up the possibility for new players to come get involved. Have we seen that well, Jan, you've got a couple of projects there. Have we seen that that effect, that once the plan starts rolling out, some of the smaller players start looking at joining in?
We don't have this project running at the moment, but the interest is there, and this is so there is two reasons to do this. As soon as everybody is certain that there will be a backbone, a CO2 backbone, where you can connect to, then there is willingness to invest to it. And the second thing is also, and that's in the UK, but also in the Netherlands, and also in Norway, and I guess also in your place, is that these areas, they want to have employment for people. And for the short term, there is no issue, but for the long term, you cannot continue with CO2 emitting technologies. So you need something for the ones that don't have an alternative. So that's one of the reasons to develop these clusters around these harbor areas, which are industrial clusters nowadays also. So have I seen it? Not yet, but yes, people are thinking about it, and we're talking about CCS for years now, and or for decades. After Paris, everybody is so the Paris Agreement. Everybody is going to take it serious in one way or the other, and they understand that this will happen at one day. That net zero is an issue. And net zero emissions, that it will come. So yes, I think it's growing.
So I'd heard from the project management team on the Northern Lights project in Norway that early on they started getting calls from chemical plant developers, for example, from around the world that said, if we build our next plant in Norway, can we play in your system? Because we want to mitigate our exposure to climate obligations. This new chemical plant is going to be operating for the next 30 years or 40 years or whatever the life of the plant is. And we need to be someplace where we know we can mitigate that risk, because it's really uncertain in a lot of other areas in the world. And they were approaching the Norwegians. Rob Mitchell, maybe you've got a sense of, is that a general pattern, or is that just one anecdote out of one particular case?
It's kind of an anecdote. It depends on where you are and depends on the interest in it, right? Everything comes down to a business case. Risking as a business risk, is it going to affect them? The biggest driver for it in Norway is, if you want to do business there, you have to do it, otherwise you're paying a lofty fee. I heard somewhere around $70, $80 a ton. You're going to do something, otherwise you're going to have to pay the fee. And the same thing's starting to happen in the US and in Canada. There is a price on carbon. Be it in Canada, we've got the stick, we've got the carbon price that basically says if you emit so many tons of CO2, for every ton of CO2, you're going to pay $50 a ton by 2022. So that's in 2 years from now. So it's going to cost you. There's political risks and uncertainty, of course, with that. Is the new government comes in, are they going to cancel that program? Are they going to fund it? What are they going to do? What happens in the future? In the States, it's a carbon credit. So you get paid a credit for it. So at least you know what that price is that you're going to get for it, so you can make a business case. There seems to be a lot of more assurances that the US credit system that they have down there is going to be more deployable. It's based over 12 years, the first 12 years that you have running for it, and the expectation that it will go further. And from that certainty, we've seen at least a dozen new projects hit the global scene in the last 6 months because of the certainty with respect to that policy. In Canada, there's still a little bit of uncertainty, plus the pain threshold's not there yet. Hopefully there's some certainty there and people can drive onto it. From an aspect of a company saying, you know what, you've got infrastructure, I can tie into it. That's kind of that notion of, here's my CO2, here's my fence, you take it from here, is exactly what Nutrien did for the Alberta Carbon Trunkline. I've got CO2, it's going up, but here's my vent goes to the end of the property, you take it from there, you dehydrate it and you compress it, you take, I don't want to deal with that. That's your business. So that's happening today in Canada, in Alberta. The challenge there is you need to find the right partners, the right actors to play those roles. So that's where Wolf Midstream jumped in for that Alberta Carbon Trunkline. And one of the challenges are, in Alberta, we had 2 projects that were announced in 2008 as part of the Alberta government $2 billion CCS fund. Those 2 main projects were the Shell Quest facility and the Alberta Carbon Trunkline. Now, the Shell Quest facility went online. It got online in 2015, and it's 5 years or 4 or 5 years quicker than the Alberta Carbon Trunkline because single source, Shell owned the facility, they owned the pipeline, they owned their storage reservoir, they owned it all, so they were able to control that, and they knew the risks and they did it. The Alberta Carbon Trunkline ran into issues because you had 2 sources, so 2 different companies. You had to find somebody that would transport it, a pipeline company. You had to get some financing for that pipeline, and you had another company for the storage. So all these parties had to get together. Plus, when you're dealing with government grants and government funding, you have to deal with the government, so you have to do that. So that's actually a 6th partner that you had to deal with. And it took a long time for those agreements to get in place, but we're seeing the fruit of it today. We see the Alberta Carbon Trunkline on, and I think the learnings that we've had from that initial get-go, it should make the next tie-in to that trunk line easier. In fact, right now they're doing a study, International CCS Knowledge Center is working with Heidelberg, which the local branch here is working on CO2 capture off of a cement facility in Edmonton. And the idea there would be it's over 500,000 tons of CO2 being captured and put into a transportation system. Obviously, the Alberta Carbon Trunkline is just 15, 20 kilometers away. You move it to there, and then you move it down the line. So you're starting to see it. The challenge is, okay, when are they going to get on board? Who do they need to talk to, and how do they go forward with it? The other thing is those 2 projects have the Alberta Carbon Trunkline and Shell Quest were heavily funded by the government. So they had government credits for the CO2 that they're actually storing. Is that going to continue for the next projects? Or is it just offsetting, I don't have CO2 emissions anymore because I don't have to pay the taxes, I pay for this instead. So it's a bit of a balance on it. But yeah, if you have a pipeline, if you have an infrastructure put in place, that bodes well for putting things online, and hopefully we see that happening in the short term.
Well, that's really good. I can think of some real directions that we could take that conversation, but I just want to start talking a little bit about Central Canada. We've got an example in Alberta, and so there's sort of I don't know, it might be a utility role or a pipeline operator role. There's somebody needs to deal with. There's the transportation. Somebody has to deal with the disposal or enhanced oil recovery, or what the sink side of things. And then there's the emissions capture, and in some cases where you're lucky enough to have pure CO2 as a byproduct, like Nutrien, it's just dehydration and compression. But there's still a front end role as well. Are there opportunities to what degree have we looked at Central Canada, Ontario and Quebec, in terms of potential for hubs and clusters or concentrated groupings of emission sources? And where once we catch it, what do we do with it?
So I think a lot of that.
Why don't I take that?
Yeah, go ahead, Rob.
Yeah, thanks.
Okay. So when we started actually doing the ICON work, we tried to understand what all of Canada would look like. We ran out of time to manage emissions on the East Coast, as Rob Mitchell's mentioned, but there's certainly some large emission sources. We did actually do a scoping for some study work right in Ontario. And you might not be as familiar with this, Richard, but certainly went through some preliminary assessments of some emission sources, market kind of assessment, and then some kind of economic sort of screening. So we had a quick look at that, and it did look like there's some real knowledge down there. Certainly a need for CO2 emission reduction in Ontario with all their heavy industry. So, just focusing on Ontario, certainly that would be a place where I would think that if we're Canadians, we should be focusing our attention and trying to accelerate CCUS development in that region. So yeah, that would be my comments.
Would there be specific locations where there are industrial clusters that might be a good starting point?
Yeah, I don't want to speak too far along. I'm kind of thinking the Sarnia region, based on my recollection, but certainly there was kind of two or three capture kind of nodes, not unlike we saw from Jan's PowerPoint. So yeah, there was a couple of clusters that looked like they might be reasonably geographically close by. So there was a few things that appeared to be of interest in some early investigations that we did.
A lot of it's focused in the southern part of Ontario. I mean, down in that area just on the Great Lakes. So you're tied into the Great Lakes. So you can move things around if you needed to ship it. You've got a lot of industrial stuff, and industry basically needs water, so they have near the water so that they can use that for their systems. And there's a lot of emissions, and the biggest emissions that they have there are cement and steel. So there are industrial emissions in there, plus there's chemical and refining in the area. For Eastern Canada, and when we talk Eastern, if you're from Alberta, everything east of Manitoba is basically Eastern Canada, but Central Canada, which is Ontario and Quebec, are the second and third biggest provinces for emissions. Quebec has done some work. They've done some small scale stuff. A small company is basically capturing CO2 off of a forestry plant where they make pulp and paper, and from that they capture the CO2 and they ship it across the road to the local food manufacturing facility where they grow tomatoes and cucumbers. And in the summertime, normally they burn methane in order to get CO2 to put into their plants. So now they're just bringing it from next door. It's perfect. And there's systems in Europe that are doing the same kind of thing on a smaller scale, but they're doing it. I think the biggest challenge there is there's not a lot of knowledge about storage. What's the storage? What do we do with it when we're done with it? So if you don't have that, that's a big risk to them. They stop there. So if that can be vetted, can be validated. I know there's oil and gas operations that happen underneath the Gulf, the Great Lakes. Shoot, just across the border down in Michigan, there's tons of pinnacle reefs that are being exploited today by Core Energy. They're actually putting CO2 in for EOR, and they're bringing it off of the shale gas CO2 that's coming from right next to them. And they've done maybe 3 or 4 of the pinnacle reefs, and they got 100 of them. That same kind of formation, I know there are pinnacles inside Ontario as well. There is some oil and gas activity there, but it's not very, nobody knows about it as much. So that's the uncertainty with it. Plus, mentioned before, how do you get the CO2 from where you are to where you're going to go? Even that cement plant in Edmonton, it's on the west side of Edmonton. How do you get over to the east side and then into the pipeline? Do you put a pipeline through a town? Nobody's going to let you put that through there. Or do you put it on trucks and you transport it on pressurized trucks? Do you put it in rail? How do you move it? Do you liquefy it? So it's just basically put in containers. Do you make it into solid ice? I don't know. There's ways that you can do to move it around, but it needs to be explored. It needs to be vetted in order for the company that's emitting the CO2 today to go forward. Because it, as you said, Richard, earlier, here's my CO2. It's in that stream here at the edge of my property. By the way, you want me to separate it from all of the NOx and all the other stuff that's in there? Well, I don't know that. That's not my business. I make steel. I make cement. That's not my business to make your CO2. So it's an uncertainty. It's a risk. And the good thing for those companies, what's being done in those other 21 facilities around the world, some of them are actually from those other industries. We're talking about the Alberta Carbon Trunkline and ShellQuest. They're making hydrogen. And in some of these locations, they're actually making hydrogen. And so there you go. We can use the same process there. So it's not like you're having to reinvent the wheel. It's tying into the network like we have here today with the 4 of us online, with the Global CCS Institute, with the International CCS Knowledge Center, with the TCM, with which is in Norway, with all these knowledge centers, all these hubs, all these people, these actors out there. We can actually get something going. We just need people, we just need companies that are interested to step forward, to join into the voice. I think everybody on the call here can, in this kitchen here, can say, hey, it's pretty open. If somebody comes to you, you talk to them. We want to connect things because we need things to go forward. It's not like a super cutthroat industry where, no, I can't talk to you. There's a little bit of that on the IP, but talking about the processes, everybody's going to have the same issues with respect to the governments, the policies, and logistics that go out there. We need to make it better for everybody to drive the costs down.
One of the you raised a really good point right there, and we can leverage what's gone before. One of the big people talk about the hardware and the technology and the equipment, and we got to drive the cost down on the equipment, and that's all true, and there's terrific progress being made on the technology side. A big part of the effort that went into getting all of these Alberta projects going is the invisible part that was done in government to put the policy and regulatory regime in place so that long-term liabilities for injected CO2, who owns the pore space, all of those debates that went on involved hundreds or thousands of people input and deep thought and effort to resolve those issues and put in those policies and regulatory regime that makes it easier to move ahead for Alberta. Also, as an example that's drawn on all around the world, that work that was done in Alberta became kind of a model that was drawn on in many jurisdictions around the world, and could possibly be useful in Ontario or other areas going forward. It makes it, once that path has been walked the first time, it's a lot easier to find your way the next time. So that's probably one of the key global benefits of the investment in Alberta that people don't talk about nearly enough.
The great thing about that too, it's all in the public domain too. So they've released all the information about those projects on the government website. So there's a lot of reports for companies that are interested. Well, what does it mean? What does it do? Well, all that's documented. It's all put out there. Those companies are required to put an annual report out there summarizing what's happened and what's going forward, and it's out there. And you mentioned it, the Alberta government's very good at sharing that information. So other jurisdictions around the world can actually talk to them in order to share and disseminate the information. I mean, as I say, it's not as much as the competitive, it's more of a, let's collaborate and get this thing moving forward, because we all know it needs to be done.
So Jan, both of your projects, being the Netherlands, it would make sense that your projects would be at ports. But you're gathering CO2 from onshore and bringing them to a subsea pipeline for offshore storage.
Yeah.
And the Norway project is loading onto ships at each of the sources are at tidewater, and so each individual source loads onto ships, transports it around to the opposite shore of Norway, bunkers it, and then injects it into a subsea pipeline for offshore injection. So they're basically ocean-going vessels almost all of the way. Is there a thought in Rotterdam or Amsterdam in terms of bringing importing CO2 by ship and injecting it into your system?
Yes, yes. So especially in Rotterdam, there are ideas, talks, etc. with Belgium, which is the southern part of the Netherlands, and they don't have storage capacity and they don't have natural resources for storage. So they talk together on how to do this. And also, this can be done by ships. Very easy. Go to Rotterdam and then bunker it, if that's the right word, and then go by pipeline to the subsurface of the sea. So that's one. On the long term, because you have the harbor of Antwerp, which is rather close, especially for Canadian definitions, it's rather close to Rotterdam. I think it's in the order of 100 kilometers or 100 and so maybe 200. But on the longer term, if this builds out, if this develops, then you go for a pipeline. A pipeline is much cheaper, but it's a big investment at the start. And by vessels is much easier for the short term, and if you need the flexibility. Another thing a reason to use vessels is if you do the investment for CO2 capture with your power plant, with your plant, and with your industry, then you need a guarantee that you can get rid of your CO2. So what if something happens? There are a number of single point failures in the system. So if you have a backup with vessels, and if you can go, for example, from the Netherlands to Norway, or we are talking to the UK and people from Ireland, and they want to have a backup solution for storage, and then this technique is very good. Go by ship and then so to release your CO2 on sea, so offshore, this is risky. You're dependent of the weather, etc. But if you can do it in the harbor, and then there is a pipeline to the empty gas field, to the storage site, this is the way to do it.
I was the distances you talk about is interesting. I was playing around on the map and saying, well, what if we looked at the sources that are in Quebec and then just went out and stored it off the east coast of Newfoundland? And I figured, well, if they're traveling all the way around Norway and then offloading at Bergen and then running it offshore, why not go around to the other side of Newfoundland? Apart from the fact that it was 4 times as far to go from Quebec to the far side of Newfoundland as it is to go around Norway.
Yeah.
Or you build a pipeline that goes across the border to the U.S., sort of like what was back done in 2000 by, that time it was Pan-Canadian, which is now, it's now been passed on to other companies, but it transports CO2 from the Dakota gasification plant up to the Weyburn oil field. So it crosses the border. So why don't we cross the border, sending it back down on the east side where we have those oil fields? That, as I said, they've got hundreds of these pinnacle reefs that can take pretty much all those CO2.
There is also some regulatory stuff in that.
Yeah, but there's been precedents by having.
Well, and just this year they solved. They've addressed some of those problems in Europe with broken down some of the barriers for moving CO2 across international borders.
Yeah, and that's also, you use CO2 for EOR, right? So CO2 used means in the Americas mainly EOR. In Europe, it's more making plastics of CO2, etc. EOR is not that common use, but if you use the CO2, then it's some, for the law this is different than if it's a waste. If it's waste, you cannot go cross border with it, or you need exemptions, etc. So it's being worked on that also in the the London Protocol. There are some amendments initiated by Norway, supported by also the Netherlands and lots of countries. But there is also a legal issue if you import CO2 and then store it in your subservice.
Mm-hmm. Yeah, the world gets complicated when you get into policy regulation and
Yeah.
especially crossing international borders. But
yeah.
So one of the biggest challenges I see out there is actually the initial cost of the capture. So you got a facility, you got an infrastructure, you got a storage. It all takes money up front before you get the first ton put into the ground. I mean, Alberta Carbon Trunkline has taken 12 years and it's finally just doing it today. So that's money that they put into the bank, put into their investment until they finally get it done. And how do they overcome that? So companies need to find investments either from governments to help them move and finance and move things forward, financial community, financial investors to invest in it, internal capital, cost of capital. Do I get money from my own company, or are they going to spend the money somewhere else and make money off of it? And this is just an expense. So there's got to be a balance and some hurdle to go overcome there. I know the Oil and Gas Climate Initiative, the OGCI, is looking for hubs and cluster projects. And if Tim were on here, he could probably he would have given us more of an understanding of that the OGCI companies are looking for areas where they can create these hubs and clusters to put that infrastructure in place, find the key anchor tenants for that matter, the 2 or 3 companies that would be willing to go forward. And from the subsurface characterization, oil and gas companies are part of the OGCI. They can help take care of the transport and the storage aspects of that. So I know there's potential for the accessing capital from those kind of ventures as well.
Yeah, and if Tim was here, I was actually relying on Tim to fill us in on what was going on the Gulf Coast down in the US, because I'm less familiar with that, but I know there's a bunch of activity going on down there and OGCI is involved in that.
Yeah, there's several locations that they're looking to basically create a hub and cluster. So they've done the same thing that we're talking about here. Rob, you were talking about it earlier. In certain areas like Sarnia or in Hamilton, where you've got a bunch of clusters of sources, they've actually held little workshops, day-long workshops for those companies to get together to talk about, well, here's what capture is, here's what storage, here's transport, here's the policy, the regulatory, here's the carbon offsets, the track, those kind of markets that you have in one day for those companies to understand what does it mean and what is it about, how can I participate in it? And at the same point in time, they say, anybody interested, come and see us. Let's see if we can put together a project together for it so that we can create a hub and cluster. I know they're planning to do 1 or 2 of them down in the Gulf Coast, and they were looking to potentially do one up here in Canada as well.
Yeah. Well, yeah, and you raised the point of the cost of capture, and the source really matters when you start talking about the cost of capture. It made life easy when everybody knew that all CCS meant was capture off of coal-fired power plants, because then you were always comparing the same. But actually, I regard coal-fired power plants as being an anomaly and not really necessarily the most important source for CO2 capture plants. But the emissions off of a fertilizer and ammonia plant is nearly pure. Cement plants are about 20% CO2. So coal plants are about 12% CO2. Industrial boilers that the oil sands guys use are about 8% CO2. Natural gas power plants are in the 4 or 5% range. And direct air capture is 0.04%. We haven't even talked about direct air capture, and that's a whole other conversation. But so, if you picture trying to to try and make that clear, if I have clear water and I get 4 drops of water and 1 drop of ink and then pull the ink back out, that's a lot easier to do. That's a cement plant. If you're going to do it from a natural gas, you got a milliliter of water and a drop of ink. That's a lot harder to pull the ink back out of that. Direct air capture, you've got a quarter cup of water and a drop of ink, and now you've got to pull that ink back. So you can understand the concentration as the concentration gets lower, it gets harder and harder to capture that CO2 and pull it out. The energy required and the cost goes up. But there are these industrial sources like cement plants and especially like fertilizer plants, natural gas processing. There are these sources where there's pure CO2 or near pure CO2 that we have to deal with. That the cost of capture isn't as serious a barrier. You mentioned cost, Rob. Do you have anything to say about that?
Well, cost. My first comment there would be, if you look at the costs that are out there today, and typically those 21 facilities are first or maybe second of its kind. And first of its kind, I mean, everybody has an iPhone or everybody has a computer. Imagine the first computer and the first iPhone that was out there. It was expensive. And if you look at that first computer, it was $40,000 that filled up like a massive room. Today, that would fit in like a quarter of your phone. So the costs go down considerably as you go through the scales. And the push is to get to the nth deployment. So cost depends on, very much depends on your source. The Shell Quest, they put it out, and even Boundary Dam, which is the coal-fired one, it's $100 to $120 a ton. But through the learnings from the deployment of the first ones, they've learned that they can actually drop the cost down to around $50 a ton for the capture. Compression's been done for many, many years. You can't really do too much on the compression. It's $15 to $25, depending on how much pressure you have and what size you need to put for it. Pipelines, it's going to be so many $1 million per kilometer of pipe that you have to put in the ground, so that we know that. And we know the storage is between $5 to $10 a ton. So you add, it's, you know, looking like $70 to $80 a ton is what it's costing. So how do we overcome that? Hopefully we get to the third and the fourth and the fifth, that we can drop those costs down to, instead of $50 a ton for the capture, down to the $25 a ton per capture. And there are some small companies out there that are claiming that they can get to that, or they're close to that today. And hopefully they can expand up so that they can get large scale deployment at that $20, $25 a ton. Because if you add all the other stuff on, it's now $50, $55 a ton. Hey, that's what the carbon tax is in Canada. That's what the carbon credits are down in the States. Now you've got a business case that says, at least I'm not spending all the money and losing it all. At least I'm covering the costs, maybe making a little bit of money, making a business case out of it. And that's where Rob K mentioned utilization. Maybe you can sell a fraction of that coming out of it for some high value products that can be converted into some kind of new coating that goes onto your walls and stuff like that, or a new chemical that can, you know, sell for $200 a ton, but it's only a small amount of it, maybe 5 to 10%, but you get a little bit of money from that, and then it makes an economic case and you can actually go forward with it. But yeah, we're in the first and second. Hopefully we get the third and fourth. And I know the big wave of projects that are down in the States, you mentioned that coal-fired plants. Well, there's actually 2 or 3 of those projects that are actually for coal-fired plants. And this ties to Jan's comment about this is people. So the coal-fired power plants, when you shut them down, those people don't have jobs. That's whole towns are shutting down. If Boundary Dam did not go forward, if they do not move forward with 4 and 5, with their turbines there, they could shut down that plant, which basically shuts down Estevan. The whole city basically was shut down. So it's people, and that's why it's not just not coal, it's also other stuff that needs to go into it. It needs to be applied everywhere.
Yeah. Great. Well, that's a really good point. I've been hearing more and more that carbon capture and storage has nothing to do with carbon capture and storage. It has to do with preserving jobs, good paying jobs in the chemical industry or whatever. And the technology part is just the details of how you get there.
And
Jan?
Yeah, technology-wise, everything is possible, but it has a price. And that means you need some incentive, and you need a business case. So that's very important to realize that. Making it cheaper, CCS will always be more expensive than emitting the CO2 to the air. So you need some artificial incentive system, like credits or cost or whatever. And the second thing, what happened in the Netherlands 10 years ago, there was, I don't know how known this, but there was the Barendrecht pilot project.
Yes.
And this was killed by public perception. And why? This was really, I say, astonishing. It was because the public, I would say, they didn't understand what was happening. They thought it could explode. And the way it was explained was that the CO2 went in reservoirs, but people thought these were big caves, and they could collapse and their houses could fall in it. So it was really, they were afraid of nonsense dangers. So things can go wrong because technicians don't understand how the common people think. They know their technology, but they don't know the psychology of the people. And also in the Netherlands, we produce gas onshore, and you get now small earthquakes, and some houses are damaged a bit, and everybody is afraid. If you say we are going to do something in the subsurface, they start shouting, and we have many people and not a lot of space. So this is also one of the reasons that we have to go offshore. Offshore, it's more expensive, but there are no people that offend to it. So also take that into account.
Mm-hmm. Yeah, well, and that's why Alberta is easy. There are holes in the ground all over the place, and oil and gas production all over the place, and people are just comfortable with it. It's a part of their everyday life. So, Rob, do you have anything else? I'm conscious that it's probably time for us to start taking some questions, see if some questions from the audience have come in. But Rob, do you have anything you wanted to add before we switch over to the listen for the audience questions? Rob Craig, sorry. We got two Robs. Robert. Oh. Robert Craig? I'm not seeing a response from Robert. So let's take a question from the audience. Have we gotten anything? Has
oh yeah, it's Julie here. We've got a whole ton of questions. So definitely we can, it's probably a good time to start going in there. So I'll kick this off. If a facility can store, for example, 1 million tons per year, what's the longevity of that commitment? For example, like what's the cumulative capacity?
Well, Rob, I don't know, who would like to take that one?
I can take a bit of it there. So it all depends on the reservoir and it depends on the contract. So this is where it's important that it's not just the source separate from the sink. You need to combine the two of them together because you need to know how long that facility plans to be capturing the CO2 and how long they need to and what volumes they're going to be doing over the life of the period. Reservoirs are characterized, as Jan said earlier, it is not a empty cylinder that's at the bottom of the ground underneath you. It's something like the gravel you see in your parking lots. That rock there actually has 4 to 30% porosity in it, despite looking like a solid rock. Now inside that pores, there's pore space that we actually fill with fluids, and that's what we're injecting into. So with the oil and gas operations over the last 50, 60 years, we're able to characterize that reservoir to tell you how much you will be able to inject into that reservoir. You don't know until you actually drill a well and start injecting what the actual properties are. But there's a whole system of exploration and characterization that oil and gas industry has put together in order to qualify that. So if you're looking for long-term, if your site's 1 million, 2 million tons, you're probably looking at 40 to 50 million ton total storage capacity. The US has done a lot of work on this. They first wanted to say, I wanted to be able to inject 1 million tons into a reservoir as part of their US DOE projects. Now they're saying, I want to characterize a 50 million ton facility that will be able to store CO2. So now, not just taking a single well, seeing that it can actually inject 1 million tons a year, but now saying it will be able to store 50 million tons a year as a storage site for that facility. Now you may link into others. You may link into 4 or 5 other companies putting together. It might be your million with another million or another million. It might be 5 million tons a year being put into a reservoir, which needs to be managed and characterized so that it can take it. The great news is there's lots of resources that can go out there and characterize it. And I know in Western Canada, we do have resources that can take that. If you just take a look at the volume of the oil and gas that's been extracted from some of these fields, we could probably fill those reservoirs up with all of Canada's CO2 for 10 years, and then they'd be done. And then you'd have to find another storage spot for it, which luckily is in the saline or the dedicated geological storage that is found below the oil and gas reservoirs, which is more abundant than the oil and gas themselves. So hopefully that answers the question.
Yeah, so as an example, the Shell Quest project, they're injecting into what's called the basal Cambrian sands, which is that deep, I characterize it as an ancient ocean of storage under Alberta that covers most of the province. It's a huge, huge formation, and there's 2 things they look at. One is how fast can you inject in a given well, and then the total capacity. When the Shell Quest project went in, I can't remember whether they drilled 6 or 8 wells. The intention was it 5?
5 wells, and they only are using 3.
They're only using 3, but they're only injecting in 1 at a time, if I understand correctly. They intended to be able to inject in 3 at a time in order to be able to take that 1 million tons a year, but the formation was able to take at much higher rates, and they have the capacity to store. Absolutely, they could take all of the emissions from Canada into that formation for hundreds of years. That's the kind of capacity that formation has. If the amount of CO2, for example, they started gathering the CO2 from the entire heartland area, Alberta heartland area, they would have to have multiple wells to be able to keep up with the injection rate. But the capacity of the formation would go on for millennium.
You manage the field.
Yeah, the field is massive. So the volumes are not, at least in the Western Canadian Sedimentary Basin, especially when you go to those deep zones, there's not a shortage of storage space there. Sorry, next question.
All right, thanks. So where are the CCS economics per ton basis now, which I'm sure is regional variation, and what might we reasonably be able to meet in the future?
Well, I think Rob Mitchell, you sort of covered that in your earlier comments, but you want to recap that?
Yeah, so we're probably looking at about $50 a ton for certain industries. Obviously, if you've got a hydrogen plant, you're probably looking in that range of about 50 tons. If you've got a fertilizer facility or you've got an ethanol facility, it's probably closer to $15, $20 a ton for capture because it's relatively pure. All you have to do is knock out some water and then basically compress it. Then you add the compression and then you add the storage, and you're looking at about an all-in between $60 to $80 a ton. Again, it highly depends on what your concentration of your stream is and on that capture cost and where you're gonna store it. So if you need to transport it, the further away you need to go, it adds to your costs.
Well, to that point, the other thing is if you've got if you can aggregate more sources and share the cost of transport, building that one-time cost of the pipeline and the operating cost of the pipeline shared across a larger volume is really drives that cost down. So treating it as a single point-to-point project makes it a much more expensive project than looking at a hub and cluster approach.
Yeah.
Rob, are you back online? Are you able to speak? Robert Craig. Robert is still looking puzzled and not saying anything, so I'm assuming he's having technical difficulties. Any more questions there?
Yeah, sure. So how much of a CCUS system can be planned up front, and how much of it relies on the systems thinking quality of emergence of a system?
Jan, you want to, because of your deep involvement in both the Porthos and Altos project, how much of putting those projects together has been a detailed planning from start to finish, and how much of it is more emergent?
So in time, you mean, or in?
Yeah, over time.
So the Porthos project started basically as the road project, where and this started I think in 2005, around that time. But slowly and surely, but this took 10 years, and then the road project started. Sorry, the Porthos idea started when road was not even finished yet. But I think it will take in the order of 10 years.
Mm-hmm.
And that's what we've seen from a lot of the large scale facilities. They take between 7 to 10 years. Usually the first 3 to 5 years is basically doing the engineering design and scoping. And inside that period of time, sometimes technologies do advance quicker than that time frame. And once you put yourself down a pathway, sometimes it's hard to change your pathway, and you might be locked into a technology. And that's almost exactly what happened down at the Boundary Dam facility for the power. So they had a coal-fired power plant. They made the decision to go with coal-fired with CCS. At that time, they were weighing that against converting it into a gas-fired plant. And at that point in time, because of the fluctuations of the price of gas, and at that time, gas was $14 an MCF here, which is pretty expensive. Today, it's trading at $2 or under $2. But because of that volatility, they made the decision, they locked into it, and then they built the Boundary Dam facility. And that took 7 years to build, to get it from the engineering design, then into the construction, which was 2 to 3 years, and then it's online. And if you look back at it and you went, oh, wait a second, I locked into a technology and we locked into a process on coal, which was cheap, and it's still cheap today, but gas would have been cheaper today if they would have moved over to it, because gas prices no longer fluctuate. Now the gas supply is steady and it's lower. So sometimes technologies do move at a different pace, but usually that 7 to 10 year window kind of locks you into what you're doing on things, which is a little bit unfortunate, because you can't just manage your change and flip and change your whole entire design of your facility, your plant, or your technology that you're going to deploy. Ideally, it would be great to have, here's my facility, and here's a pipe coming out of it, and I just bolt on a prefabbed kind of skid unit that basically takes it, and out comes the CO2. Practically, that's not applicable yet today, although there are some smaller companies that are looking to try and do that, to make it modular, so that we can, just go bolt on. When that's done, just undo it and move over to the next one, which is not as easy as that seems. There's still a lot of work to bolt on. It's a lot of connections that have to be put in place, but we're not there yet today. And hopefully, eventually, you'll get into the mass manufacturing, you'll get into the wholesale mold of making these, and we will get efficiencies that will come from the engineering and the construction of the facilities, which will drop the costs even further from the $50 to $80 I said earlier, down to hopefully, again, as I said, $20 to $30 a ton for capture would be ideal.
That's a really good point, Rob, because right up until now, the focus has been sort of million ton a year as a standard size, million ton plus a year as a standard size, and everything is focused on economies of scale and how do we drive the cost of capture down. But once you've got the infrastructure in place and you're thinking about systems, then maybe the economics may make sense for 100,000 ton a year, or even smaller, or in the range 100,000 to 500,000 starts becoming reasonable. Maybe it's 50,000 tons a year down the road. So and there's a lot more of that scale of emission sources than there are of million plus ton a year. But again, nobody's going to build a 50,000 ton a year capture plant and the pipeline.
No, then it'd be trucking or something else, because the pipeline doesn't justify for that means. Just a little note on that, as I mentioned off the top of the get-go, Canada has reported emissions based on the 2018 figures. It's all on the Government of Canada Environment website. You can actually pull the data down for the emitters that went out for those 1,700 facilities. That's 281 million tons of CO2 that's being documented as being emitted from these facilities. 166 of that comes from 59 large facilities. So you can put 100 of these small little things and not make a big dent in the CO2 emissions, or you can go to these large emitters that, as John, you mentioned, 10 million tons. You got 8 million tons coming from one facility. That makes a dramatic impact on a region's CO2 emissions footprint, rather than 500 of these small little ones that add up to the same thing. Right?
Rob, I'm gonna challenge you on that. There's one word I would change.
Cost.
You said or. You said or, and I would say and.
And yes, you need to do and. And it might be easier and more cost prohibitive for the large scale, because those large ones are going to cost you $1 billion, where that small scale one might only cost you $50 million. Now, it's easier to go get $50 million than it is to get $1 billion. So maybe it's easier to go out there and do the small scale stuff now if you can get it connected up to one of these pipeline systems.
Once the pipe is there.
Yes, and the pipe only comes if there is a big one, eh?
That's exactly right. You need the anchor tenants. That's the point in the UK is they're doing these industrial hubs and clusters, and a big part of their decarbonization is going to hydrogen. Yeah. So what they're doing is their anchor tenant is natural gas to hydrogen conversion, and then they're distributing hydrogen to a lot of the smaller scale heat sources, industrial heat sources, which basically you've transferred all of the emissions from all of those heat sources up to the hydrogen conversion plant instead of having all of these small distributed sources. And then once that's paid for the pipeline, then there's other emission sources that can pull into it. I think that thinking in terms of, and we don't have time to go into it, but hubs and clusters as being both a hydrogen hub and a CO2 hub and cluster working together, there's some interesting synergies there. Anyway, any other questions?
Yeah, we have one more question. Actually, I'm going to hand it over to Dave Urkel to ask that.
This is a doozer of a question, gentlemen. The question is it possible, based on Canada's infrastructure, our current natural gas infrastructure, do we have the ability or the capacity of actually making this a national initiative and collecting the carbon from those large emitters and then transmitting it back to Alberta? Is there economics of doing that type of thing as a national initiative?
That's two questions. Is it technically possible, and is it economically achievable? Yeah. And there's three questions. And is it politically achievable?
So we've got a gas line that goes to supply the gas to the east. That has established a right-of-way that you can actually go and put another pipeline on. The challenge is you cannot use the same natural gas pipeline to turn it around and send the CO2 back onto the west. So in order to do that, you'd have to make a CO2 pipeline. So you'd have to make that 2,000 to 3,000 kilometer pipeline, which costs money. So who's going to pay for that cost. So if the government wants to put up that money and do that, and this is going back to the state-run thing, like what they do overseas, or what was mentioned in other areas, you have to have the government step up and do that, or somebody has to do that with a long-term contract with guaranteed this is the amount of CO2 going down it for them to actually put the investment and actually construct it, which is what happened to the Alberta Carbon Trunkline. So they've got that long-term stability, and they've got that pipeline paid for, so they're going to do it. It's actually the Ontario pension fund, the Canada pension fund that is actually funding that pipeline for the Alberta Carbon Trunkline through Wolf Midstream. So it's a long-term, they're making money off of it, but not as much as, say, a capital investment from the stock markets and stuff like that, or other capital stuff, but they're making a little bit of money with the initial tenant agreement. Once they get more people coming on board, it'll actually make even more money, and it'll cost less for Enhance and the others that are actually paying tariffs on it, right? So you need to have that long-term commitment for it. It can be done. The challenge is, do you put it all the way back to the west, or can you find a closer sink for that CO2 to go to? The other side of it is you need to have that CO2 with guaranteed amount of CO2 going down that pipeline in order for it to be built. Otherwise, it will never be built. And politically, answering Richard's question, the same thing. We're having objections to basically increase the size of CO2 of methane that we're sending to the east and putting oil to the east to get it to ship to tidewaters on that eastern side of the country. We're never going to be able to get a cross-Canada pipeline put forward with CO2 unless the political environment for the government, the federal government says, nope, we're doing it. We're going to take federal jurisdiction, and we're going to buy it, like they did the pipeline going Trans Mountain to the west, and they make it themselves, which will inevitably cost more money. It'll be paid for by the taxpayers, and it's probably going to be political suicide, but it can be done. But yeah, somebody's got to pay for it.
Yes, as the old Yes Minister show used to say, a courageous move, Mr. Minister.
Yeah. Great.
All right, well, I want to thank you guys very much, and I apologize to Rob Craig, who did indicate just recently that he was having trouble hearing anything on his end, so I want to thank you guys, and I want to thank to Rob, even though he's not been able to finish off the webinar. I think we had some really great discussions today, and some really great answers. I just want to thank everybody for their attendance today. Please do, if there was any other questions that you think of afterwards, or you didn't get a chance to ask, please let us know, and we can definitely put those questions to our panelists here and get some answers back to you. So once again, thank you very much. The recording of this webinar will be up on our website within the next few days, and we'll send you guys out a notice once that's up. So thanks again so much, gentlemen, and hope you have a great day.
Thank you.
Thank you.
And you too. Bye-bye.
Bye. Maybe we can do it again.
Yes.
That sounds great. You take care.